Well, let's find the roots of this quadratic equation by completing the square. And I'll tell you ahead of time that this one has imaginary roots. So we start by, as usual, putting the constant term on the right side, and we do that by subtraction. The next thing is to divide the coefficient of x squared away, so we'll divide everything by 3 to get x squared minus 4/3 x is equal to minus 7/3. And then we complete the square by adding 1/2 of 4/3, squaring that on both sides. I'll write it as 2/3 squared on the left and just 4/9 on the right. And then right away I'll go ahead and change that minus 7/3 into minus 21/9, just so we'll have a common denominator here that we can add. And that's going to give us minus 17/9. I like to finish off that right side as soon as I can. Alright, we identify the perfect square on the left. It's x minus 2/3 quantity squared. And again, you can just read that off of this way we've written this up top here. And that's equal to minus 17/9. Take the square root of both sides, so we have x minus 2/3 on the left is equal to plus or minus I root 17 over 3 on the right. Then we can just easily finish off solving for x. It's 2 plus or minus I root 17 all over 3. And so we have two complex solutions with non-zero imaginary parts. And these always come, remember, in pairs of complex conjugates. And remember that complex conjugates just have a different sign on the imaginary part. Okay, let's just do one more thing while we're here. Remember, we've talked before about the discriminant. The discriminant is just the part in the quadratic formula underneath the radical. It's b squared minus 4ac. And we could have used it in this problem to determine whether the thing has imaginary roots or not from the beginning. And so b squared minus 4ac in this case turns out to be 16 minus 4 times 21, which is certainly less than 0. And when the discriminant is less than 0, we have imaginary roots. So that's a nice thing to use before you even get started in these problems.